Here's Anatoly again, and in this video I want to show you something interesting. So I have the simulation of P6 converter in Simulink environment in PLECS block set. And if I open it, we see that it's the classic P6 PFC, and let's just simulate it. So you see that simulation works, and it is rather slow, so it's going on, and it takes some time. Let's just wait until it finishes. So now let's close it, so we save some memory and run exactly the same simulation in PLECS Standalone. And you already see it runs way faster, several times faster. As we know, a lot of people still prefer using Simulink and block set PLECS for at least two reasons. The first one is that they can use the blocks, some pre-developed blocks that they can attach from Simulink to PLECS. And the other reason is they still want to use the results from PLECS simulation and then manipulate it in Workspace MATLAB environment. And actually, we can also control the simulation in standalone from MATLAB. So I developed a class called MATPLEX, and underneath this class, I used JSON communication between MATLAB and PLEX that was provided from PLEXim, and you can find it on their GitHub. The way it works is that I need to create an object of MATPLEX. Let's call this object P6. And then we need to provide the model name. In our case, it is called P6. So we run it. And we see that it is connected to the PLEX. So maybe we can see the window here. And now we can select the function called simulate. Here, the first thing we have to provide is the names of the output signals that we give. And in our case, it should be a vector. It is VDC, it is duty cycle A, duty cycle B, duty cycle C, A phase voltage, B phase voltage, C phase voltage. The first thing we can do here, we can plot it right after the simulation is finished. For this, we need to specify the attribute plot as true, and then we also need to define the structure of how we plot in it. So now if we simulate it, we see that simulation is running. So basically we could simulate it from MATLAB and we see that it works. Now, after the simulation is finished, we have to wait a little bit. So the results from PLECS, they're going inside MATLAB. And the simulation is finished. We got the results. We have the results plotted. And this is not exactly the plot I want to have. So one thing we can do right away is to change some parameters. So in our case, we can change the DC voltage, for example, and see it immediately how it responds. So we need to use the command add_param. Here we say VDC, and then let's give the new value 900. Yeah, so we're not plotting it anymore. Let's run only this and see. Yeah, so the VDC is changed to 900 now. We can also change the frequency, switching frequency parameters. We can also change the inductance, the capacitance, whatever is in our initialization file. So now when it finished, let's plot the results in a separate function. So we have plot results, and here I can just copy this vector again. And then I provide the same structure, 1, 3, 3, 3. But what I want to do, I want to limit the x-axis or something between 0.44 and 0.5. Okay, and now I also want to change the y-axis, and for this I'm using the attribute ylim, and here I need to put a matrix. So for the first one it will be between 0 and 1000, semicolon. This one between -1 and 1, semicolon. -400, 400, semicolon. And now let's plot it again. So I think it is way better now. What else we can do here is that we can find RMS of some parameter we have here, for example, phase current or FFT. Let's see the FFT of duty cycle A. And yeah, let's run it as it is. So I think it will give the full FFT. But what I want to change, I want only to see the first 3 harmonics, so I will put something like xlim between 0 and let's put 500 Hertz. Now if I run it, so we see, because it is space vector modulation, we have the first harmonic 50 Hertz at 0.7, and then we have the second harmonic at 150. So basically this is what corresponds to space vector modulation. If we don't want to use the functions that are provided with MATPLEX and want to see the results directly, we just need to go to the structure results, and here we have time, and we also have exactly the same names as we provided here. So it is VDC, DA, DB, DC, and let's plot it using standard function. So it is P6 results time and P6 results DA. Now let's plot the other ones. So let's plot all 3 phases. So it should be DA, DB, DC. Yeah. And basically you can play with it using the standard MATLAB functions that you got used to. And I will link this class and some examples in my I will link this class and some examples to my GitHub, and please continue watching my channel, subscribe, and hit that like button, and see you next time.